Straight line graphs. There are two types of problems we'll have to deal with. One problem is when we are given the graph with two known points, and another problem is when we are given the equation of a straight line and we have to then sketch the graph. So let's look at this first case when we are given a graph and we have to write an equation for it. Then we will look at the second case when we are given the equation and need to sketch the graph. So let's just have lots of space here and draw the graph again. So you are given 2 points. The first thing we see is, because this is a straight line, it has to follow the format of y equals mx plus c. We need to know that the c, the independent term not associated with x in this equation, is always going to be the y-intercept, and the one we always start with. So to identify the y-intercept, all I need to check is where the blue line crosses the vertical axis, the y-axis. So straight away we know it's in 3. So I can even rewrite that original equation as y equals mx plus 3, because that's where the blue straight line crosses the y-axis. Now we have to look at the number in front of x. That is called the gradient, and we know it's always going to be what we say, the rise over run. So from that pink point 3, we have to get, from this point 3, we have to get to the point 2. So, well, point 03, or the y-intercept, from there we have to get to the 2. So the easiest way here is, we're going to have to go down, and then you just count how many units. Well, it's the length of that part in purple. So the length there is 3, but because we're going down, it's going to need to be -3. So this is the rise. The rise going up will be positive and going down will be negative. From here, we have to now go to the right to get to the point 20. Again, the length here is 2 units, and because we're going to the right, it is positive. So that means our equation can be finally rewritten as m substituted as -3/2 x plus 3. So that is from the graph writing the equation. So now let's see from the equation, the second case I said at the start, when we have an equation and we want to sketch the graph. So this format is not ideal for quickly sketching a graph. So what we need to do is rearrange this formula for y, transpose the formula for y. So that means we have to remove the 6 and the 2 to make sure only y is sitting on the left hand side in this case. Could be on the right hand side as well. So first thing we do is we remove the 6 because it's the one that is further away from the y. So we can rewrite this as 2y equals 4x. Now that 6 that is an addition with the 2y is a positive number, so it's adding, so we will subtract it. We technically subtract it from both sides, but of course it simply disappears from the left hand side. Now all we need to do is remove that 2 so that the y is on its own. Now the relationship between the 2 and the y in this case is multiplication. So we have to divide both sides by 2. And I say both sides, it's not just one term or another, both sides, everybody. So on the left hand side the 2's disappear, and on the right hand side we can break this fraction apart because we know 4x is sitting over 2, but we know that the 6 is also sitting over 2. To finish off, we simplify. 4 divided by 2 here we'll have 2, and then 6 divided by 2 there we'll have 3, negative 3 of course. So now this equation, or this law for the linear function we're talking about and the graph we want to sketch, is a lot easier to do. So let's sketch the graph. So let's copy the formula here on top again, and now we'll do the 2 axes. So where do we start? As I said originally, always with the independent, not associated with x, the y-intercept or c. So we just need to go to the y-axis. There it is, negative 3. That's where the straight line is going to cross y. We don't know where it's going to cross x at this stage. The quick method will be simply to look at the gradient, the m in front of the x, the number that multiplies x, and we know that is being the gradient, it's the rise over run. So the rise here is 2. There's nothing sitting on the bottom, but we can always imagine a whole number as a fraction over 1. So what we're going to do, from the blue point 0, negative 3, we're going to rise 2. So let's go up 2 units, which takes us to the negative 1. And then we have to go across to the right because it's a positive 1. So we went up 2 units, length. We went across 1 unit. So this is the 1. And that's the new point. So I'll just go in a different color with that point there. And that's our straight line. So all we have to do now is link those points. A ruler would be good. So the only 2 points that we really know from this, or for this sketch, will be the 0, negative 3, the y-intercept here. And then from the rise over run, we know that that little green point there, that is actually, if we needed the coordinates, it would be 1 for x, negative 1 for y. But so long as we show it here and here, we know the coordinates have been labeled. Suppose the last thing that we could talk about would be if you are given a graph, that's like the first case, given a graph but no intercept necessarily in the y-axis. So let's say we had, well, it will always intercept, but let's say the given point was something here. So, oh no, and it was just basically the coordinates given to us, like 4, negative 1. And yes, let's have an intercept here. Let's say this is a 3. So what would we know? It's a straight line, so y equals mx plus c. Always start with a c if you can. So the c or y-intercept in this case is that 3. Can rewrite the formula as mx plus 3. Now what we do is we go from that 3 to the other given point. If the coordinates are stated, what we know is we could even just project the point against the y-axis to know what this is, and from the coordinates that are given, the second one is always the y, negative 1, and projecting here to the x, I know this must be the 4. So x is 4, y is negative 1. That helps me find the length of the rise over run. So we need now to find for the m, the rise over run. So from the red point, the y-intercept, I have to go down to get to the other red point. So I have to go down this length, which is 3 here and another unit there. So we're talking length, so we don't worry about the negative sign at this stage. So the total of 4 units going down. So that means negative because of the direction we're going down. From here, now we have to go across, and then we just need to see what length there was. So if we have labeled the 4 in here already, we know this is 4 units as well. So down 4 units, meaning -4 for the rise, across or to the right 4 units, meaning 4, +4 to the right. So simplifying this, we get -1. So we can go back to our equation and write y equals, instead of m, -1x plus the y-intercept 3. Could even just drop that one, y equals -x plus 3.